Yeah, welcome back to the second video of this lecture. I next would like to explain another approach that is aiming at improving user experience, and that is about explainable static analysis. So explainability has been a very hot and trending topic in different areas of computer science over the past few years. So there's actually also a larger collaborative project here at Paderborn that will work on explainability for artificial intelligence. But it's also an important topic for static analysis because actually many years ago, already even some commercial vendors of static analysis tools have reported that they had huge problems with this. It even went so far that, these tools became better and better at computing more and more complex, security vulnerabilities. So the tools would really find very intricate security vulnerabilities, for instance, in C programs. But then it turned out that users would not actually believe the tools, right? So they would think, oh, this can only be a false positive, a false warning, because it's so complex that I don't even understand what this code does. And then, they would actually doubt the tools, and that's twice as bad, right? The tools are very good at finding things, but then the users, they actually dismiss these real vulnerabilities anyways, right? And obviously that's very disappointing. And so we started looking into how one can do this better. And we came up with this prototypical solution of so-called rule graphs. What is the idea about? Well, the idea is basically, as you see on this slide here. So let's assume we are having some taint analysis problem. For instance, here we have some parameter to a web service that can actually be considered a source. And then maybe that can end up in some SQL query, right? Like you see here. So that could actually be a SQL injection problem. Or here you can also have another SQL injection here. And I think that is some open redirect vulnerability that you have down here, right? And so we have three different kinds of taint flows. And, this is now still rather simple code, but you can imagine it could also be more complex. And then users might wonder, is that really a taint flow? And if so, why, right? Because in the end, the users also have a point, right? So as you know, static analysis, they still need to approximate in several situations. And depending on how good or how bad your analyzer is, you might have larger false positive rates. And then it's hard for the user to really figure out, is this now a false positive because there was some over approximation, or is it actually a true warning, right? And so the idea is that we would annotate these flows with the rules that actually cause them, right? So for instance, up here, we see that this parameter was actually assigned to an array, okay? And in particular to an array index 0, right? But then what is being accessed here is actually, what is being assigned here is actually a different array index, okay? But here we are accessing this index, right? 1. So we are actually accessing the safe value, and we are not actually accessing this attacker controlled parameter value here, okay? So what you see here is actually a spurious taint flow. So actually we are seeing a false warning here. But why is that a false warning? Why does the analysis cause this? Well, because it has this array rule that basically says whenever something is assigning anywhere to the array, I'm tainting the entire array, okay? And that is the over approximation that's happening here. And now, if as a user, you have understood that this array rule is working like this, right? So whenever something is assigned to a single index, the entire array is tainted. And by looking at this, you might get an intuition that maybe there's already some approximation going on here, and maybe therefore that is not actually really a true positive. It might be, right? But we're not sure. And by looking at this line of code, you might actually make sure. And getting these rule graphs is a first step into this direction. This could probably still be improved by then prioritizing on these lines and pointing to the user to this. And in fact, there's also been related work that looked at then computing such constraints. I remember there was a paper by Ishil Dilek a few years ago where she and others actually looked into this. So you would basically generate constraints and asking the user, was the value now really assigned to this particular array element or not? And then the user could just answer that simple query. And then, depending on this, you could then actually dismiss this warning or not. This is what the extended algorithmics look like. So again, this is just and what you see in black here is regular data flow functions for the taint analysis that we had implemented there. But then here that would be augmented with additional metadata that basically keeps track of these rules as they are computed. So this is an identity rule that we have here. So it will get this ID tag. Here, this is code that is actually recognizing and handling a source. You see that here. So this is tagged with source. This is the statement that's actually handling array. So this is tagged with array and so on and so forth. And then using this metadata, you can actually display this in a tool. So we had this prototype tool that is called Mudarri. I think in this case, it was actually integrated into IntelliJ. Yeah, what you see here is really basically this annotation. So by looking at these warnings, you can actually step through these different lines of code. And then the UI here would actually tell you what kind of rule had been applied, and also would give you even a little bit of an explanation for it, right? So this would tell you the right-hand side of the assignment is tainted, and therefore the local variable on the left-hand side is tainted as well by this parameter rule here. Okay. And yeah, this is the paper about it. So if you're again interested in any details, I encourage you to take a look online. Then there's a third topic I just very briefly really wanted to mention here, because I also think it's an interesting and fruitful line of work. So this is about gamifying static analysis. And so basically the idea is, wouldn't it be fun to have static analysis tools that were more fun, right? More encouraging? Because obviously debugging any sort of program code is typically not much fun at all. I mean, there are some people who maybe like it, but I think they're definitely in the minority. And so a static analysis tool as such is having a hard time of being a tool that people like, right? I mean, it's telling you basically that you have more work to do, right? And so that's often rather discouraging to people, and they might not really appreciate it. And so we thought that it might be helpful to actually turn this into a bit more of a challenge or a competition, right? And maybe reward people for not just identifying, but also fixing bugs. And yeah, I don't want to go into detail here, but we basically had some mock-ups, right, of how you could actually have different interactive sort of user elements, and also have more of a community spirit to the whole thing, right? So maybe you could earn some scores, like you can see here, by fixing certain bugs. And you could then also have competitions between different users in the same development team, for instance. So we wrote an idea paper about this at ESEC FSE 18, where we pitched the idea and also wrote a little bit about these concepts that we thought of. Unfortunately, so far we did not yet get around actually implementing and trying this and really running user studies on this. So that's still an open topic for the moment. But I would really like to see more work on this, and I think it will be a very fruitful topic to pursue. Yeah, that actually concludes everything I wanted to tell you about improved user experience and static analysis. I'm pretty sure there's much more to be done in this space, and there can be many more interesting and truly useful concepts. We are continuing this line of work with a couple of PhD students. So if you are interested in working with us on these topics, you're more than welcome to contact me, and we will likely get in touch with you and see whether we can work on this together. With that, I just briefly want to also conclude this entire course, just to briefly recap. First of all, I hope you enjoyed it. So I presented to you a mix of still rather foundational, but then also applied topics. So in the beginning, we talked about different IFDS and IDE extensions, such as sparse IFDS and also SPA-Lift, our product line analysis. Then we talked about this concept of pushdown systems as a sort of extension to IFDS or different formulation of IFDS, and weighted pushdown systems as a sort of equivalent formulation of IDE. And then I also explained to you the very important concept of demand-driven analysis and then synchronous pushdown systems that bring this here together. And I explained to you how we use that to implement the really highly efficient and precise pointer analysis boomerang. And on top of all of this, the crypto analyzer CogniCrypt. And then in the second half, we saw the FlowDroid tool as a tool that really combines sort of IFDS-style taint analysis with some rather sophisticated call graph analysis for Android. Then I talked about dealing with reflection, right, with the Tamiflex tool in particular. There's another interesting tool I did not get time to talk about, but that you could also take a look at. So that's the tool Judge by the Software Technology Group at TU Darmstadt. I think that's also a very interesting tool in this space. And then I also talked about Harvester and Heapster, which are tools for hybrid static and dynamic analysis. Then Goran talked about FluentTQL and Swan Assist as tools for customizing static analysis, in particular static taint analysis. And last but not least, today I talked about improved user experience and gamification. So this is already covering a lot in the static analysis domain, but there are many, many more fields. For instance, there's an entire subfield that I did not really explain in detail here, which is on abstract interpretation. Also, of course, static analysis is bordering formal reasoning techniques, such as automated program proofs or even program synthesis or model checking. I cannot cover all of this in this course, but all of these fields are rather related. So if you're interested in getting an even broader view of the entire field, I encourage you to search for other courses that cover these topics as well. Yeah, with that, I'm actually done with my course. I really hope you enjoyed it and you had a good time. I already received some feedback through our YouTube channel and also by personal mail. If you liked or also disliked parts of the course, please do let me know. We are always eager to improve this. And yeah, I hope you will also stay tuned for more. So you are most welcome to also follow us on Twitter. So we have our own Twitter channel for my research group where we announce every now and then when there's a new publication or maybe also some new course videos that are coming, other interesting news. And obviously there's our YouTube channel, which I have again linked here, where you will also find further videos. We actually also have a full C++ programming course aimed at early bachelor's level, which also tends to be very popular, at least at the university here. And yeah, I really hope you will take advantage of this as well. So with that, yeah, I wish to thank you for your attention, and I hope to see you again soon. Bye-bye.